Howdy, welcome back. Today we're going to do the derivatives of inverse trig functions and its implicit differentiation, aka the chain rule that lets us do it. Alright, so first of all, remember there's this alternate notation for the inverse trig functions. One way to write the arc sine of x is also as sine to the minus 1 of x. Remember, that's not 1 over sine, it's the inverse sine function. Similarly, there's arc tangent, which can also be written as the inverse tangent function, and the arc secant function, that can also be written as the secant inverse of x. I tend to use the arc sine, even though it's longer, because that minus 1 power can be confusing, whether someone means the inverse function or a negative 1 power. Alright, so here's the theorem, the statement of what their derivatives look like. The derivative of the arc sine of x turns out to be 1 over the square root of 1 minus x squared. The derivative of the arc tangent is 1 over 1 plus x squared, and the derivative of the arc secant is 1 over, well, technically square root of absolute value of x, x squared minus 1. There are arc cosines and arc cotangents and things like that, but really these are the three that are going to matter most for calculus, especially when you start doing integration theory. All right, let me tell you how this works, at least for the arc secant, and then let's do an example first, and then I'll tell you why that works. So if I do d by dx of the arc sine of x to the fourth, this is a chain rule problem. The outside is arc sine, so its derivative was 1 over the square root of 1 minus x squared, but we have to plug in the inside, which is x to the fourth, and then times the derivative of the inside. So altogether we get 4x cubed all over the square root of 1 minus, well, when you plug in x to the fourth to the square, it'll give you x to the eighth, because exponents multiply. All right, so why does this work? Well, let's figure out what's going on for the derivative of the arc sine. And it really all goes back to the fact that the arc sine is the inverse function for the sine. So what that means is the sine of the arc sine is back to x. Because remember, whatever arc sine does to x, sine undoes it, and vice versa. So the trick is just to take d by dx on both sides, just like implicit differentiation. So what we get on this side is just a 1 on the right side, but the left side, you have to do the derivative of the outside function. So the derivative of sine is cosine. And then you have to plug in the inside function, arc sine. And then you have to multiply by the derivative of the inside function. And we don't know what that is yet. So let's just write the derivative of the inside function. However, you see this is an equation we can solve. And we can solve for the derivative of the arc sine here. It's just 1 over the cosine of the arc sine of x. Well, that's an answer. It tells us an answer. The problem is, what on earth is the cosine of the arc sine of x? So the way to think about this is, if you remember, the arc sine is supposed to be an angle, so let's call it theta. So let's let theta be the arc sine of x. And what that means, it's related to trigonometry, right? So if this is angle theta, well, if I'm saying that theta is the arcsine of x, that's the same thing as saying the sine of theta is x, because that's the definition of what the arcsine is. So if the sine of theta is x, think of it as x over 1, then that means this triangle, the opposite over the hypotenuse, should be 1. So let's write it this way, x and 1. Now I don't know what this side is yet, but I do know by Pythagoras that I get 1 is x squared plus a squared. So I can solve for a. Namely, a will be the square root of 1 minus x squared. So that this side is the square root of 1 minus x squared. All right? And in particular, the cosine of theta will be the adjacent over 1, so that'll be the square root of 1 minus x squared. So that lets me, remember, theta was the arc sine of x, so I can take this guy and stick him all the way over there to get the final answer. So the final answer will be 1 over the square root of 1 minus x squared, which is what we had in the theorem. And all those inverse trig functions can be done exactly the same way. Take the derivative of both sides, draw a triangle, use Pythagoras, and get your answer. All right. Ciao.